Today we're diving into one of the most groundbreaking ideas in physics, the theory of relativity. Developed by Albert Einstein in the early 20th century, this theory completely changed how we understand space-time and gravity. Before Einstein, people believed that time and space were absolute, unchanging backgrounds to everything that happened in the universe. But Einstein showed us that these concepts are actually flexible and interconnected. In this video, we'll break down what relativity means, why it matters, and how it affects our everyday lives. Let's start by exploring the basics of this fascinating theory. Albert Einstein introduced the theory of relativity in two main parts: special relativity and general relativity. Special relativity came first in 1905, and it focused on how the laws of physics are the same for all non-accelerating observers. This means that whether you're sitting still or moving at a constant speed, the rules don't change. Einstein's insight was that the speed of light is always constant, no matter how fast you're moving. This idea led to some surprising conclusions about time and space, which we'll explore in the next scenes. One of the most mind-blowing aspects of relativity is the idea that space and time are not separate things. Instead, they form a single fabric called spacetime. According to Einstein, events that happen in the universe are described by their position in both space and time. This means that what you experience as now might be different for someone moving at a different speed. The faster you move, the more time seems to slow down for you, a phenomenon known as time dilation. This connection between space and time is at the heart of relativity. Let's take a closer look at time dilation. Imagine two twins. One stays on Earth while the other travels on a spaceship at nearly the speed of light. When the traveling twin returns, they will have aged less than the twin who stayed on Earth. This isn't science fiction, it's a real effect predicted by special relativity and confirmed by experiments with fast-moving particles and even atomic clocks on airplanes. Time dilation shows us that time isn't absolute, it depends on how fast you're moving relative to others. After special relativity, Einstein developed general relativity in 1915. This theory expanded his ideas to include gravity. Instead of thinking of gravity as a force pulling objects together, Einstein described it as the warping of spacetime by mass and energy. Massive objects like planets and stars bend the spacetime around them, and this curvature tells other objects how to move. That's why the Earth orbits the Sun, not because it's being pulled by an invisible force, but because it's following the curved path in spacetime. General relativity also predicts some amazing phenomena. For example, light bends when it passes near a massive object like the Sun. This was first observed during a solar eclipse in 1919, confirming Einstein's theory. Another prediction is the existence of black holes, regions where spacetime is so warped that nothing, not even light, can escape. These ideas have been confirmed by astronomical observations and have changed our understanding of the universe. You might think relativity only matters for scientists, but it actually affects our daily lives. For example, GPS satellites rely on both special and general relativity to provide accurate location data. Because satellites move quickly and are farther from Earth's gravity, their clocks tick at different rates compared to clocks on the ground. Engineers must account for these differences, or GPS would quickly become inaccurate. Relativity is essential for modern technology. Scientists have tested the theory of relativity in many ways, from observing the bending of starlight to measuring time differences with atomic clocks. Every experiment so far has supported Einstein's predictions. Even as we search for new physics beyond relativity, this theory remains a cornerstone of our understanding of the universe. Its accuracy and reliability have made it one of the most successful scientific theories ever developed. Summary: the theory of relativity revolutionized our view of the universe. It showed us that space and time are flexible, interconnected, and influenced by mass and energy. From black holes to GPS, relativity shaped both our understanding of the cosmos and the technology we use every day. Einstein's insights continue to inspire scientists and thinkers, reminding us that the universe is full of surprises, waiting to be discovered. Thanks for joining us on this journey through relativity.